So in this chapter 4, we're going to start percentages. In chapter 3, they do other stuff. They do linear regression and correlation. I'm going to skip over that. I'll come back to it if necessary, because I know we do a little bit of statistics near the end. So if necessary, I'll come back to linear regression, but we'll see though. Odds are I won't. There's only so much, I only have so much time in the course. So, but now we're going to do percentages. Percentages, they're all around us, right? You hear in the news, or you see at like stores and stuff, the price of something went up or went down a certain percent. 10% of the students on campus did this or did that. You see percents everywhere. But what does that really mean though? Well, percent really means per 100. That's really what percent means. So if you have like B percent, whatever that is, where B is a number, really what they're saying is B over 100, or in decimal form, 0.0B. So like 10% would really be the same as 10 over 100, or it would be the same as 0.10, 0.10. Okay, that's really what we're saying here. So 10%, 10 over 100. So, yeah. I mean, as a decimal, you could convert that by moving the decimal to the left 2 spaces. So this might be a little misleading, but hopefully you get the idea. And one example of that would be, here. So one example of that here, let me just cross this out. One example of that would be like 1 over 5, right? Well, you can actually convert a fraction to a percent. You just need the denominator to be 100, which 1 over 5 is the same as 0.2, which is the same as 0.20, 20 over 100, which is 20%. Again, this is really just a definition of what a percent is. So 98% would be then 0.98, which is 98 over 100. When you divide by 100, the decimal goes to the left 2 spaces. That's all I'm doing there. But that's just what a percent is by definition. So when you see like, B percent, that's really the same as B over 100. If you want, you could think of it as moving the decimal to the left 2 spaces. And I crossed this out because I thought it was a little misleading, but really that's what we're doing now. All right. Anyway, we have this definition as well. There's also this notion of part over whole, and percent is the same as part over whole, where percent is a decimal. So 12%, this would be like 0.12, for instance, and you have that's equal to part over whole. I know some places use is over of, same thing. Same exact idea. I mean, the one advantage of is over of is that usually whole comes after of. Part is associated with the word is. So sometimes that can help with the wording. So you could do it that way also. It's just that in the past when I've taught this, and not this course, but I've done percents, and I tried is over of, and the students were more comfortable with part over whole. Maybe they were used to it. I don't know. So, but whatever, it's okay. But here's an example of that. Suppose the sales tax in a town was 12.1%. Okay. We want to know how much tax you're going to pay if you spend $100. So remember, tax is part of the whole purchase, right? So tax is going to be where part is. Whole is the entire purchase. So for the first one, we're going to have this. Whole, again, is our purchase. Tax is the part of it. So I think I messed that. No, this is right. So here we have 100, right? That should be tax over 100 equals percent. Oh, no, I see what I did. Okay. So basically what I'm doing here is I'm using this. Where percent, right? Percent, I'm dividing by 100 because percent here is normally a decimal. But instead of converting it to a decimal, I divide it by 100. So that's what's happening here. Okay. So again, basically I'm starting out with here. I'm not showing all the steps, but I'm using this equation where part is tax, percent would be 12.1 written as a decimal, meaning you move the decimal 2 spaces to the left, which is the same as dividing by 100. And whole, I have purchase over here. I didn't show all the steps, but hopefully you can still see that the tax would be $12.10. Does everyone look? Oh, wait. Okay. Actually, hold on a second. Does that make sense? The first example, part A at least. I feel like I messed it up a bit. Yeah, let me do it this way then. Polling. Wait, someone said all good. Oh, someone said all good. Okay. Let me check though. That's one person. I want to check everyone.
I just have a question.
Yeah.
So where it says percent over 100, are you going to put 12.1 or are you moving the decimal?
I put 12.1 over 100. When you move the decimal, you don't have to put it over 100.
Oh, okay.
Does that? I hope that helps.
Yeah.
Again, I didn't think we got this far. So in the other class, you know, it didn't go as well. So, but I'm hoping it goes well here. So we'll see. Okay. Someone said no. Again, if you have a question, don't be afraid to ask. So yeah, I might have to do this again next time, but that's all right. We'll just keep going for now, I guess. I don't want to end too early. All right. Okay. All right. Okay, so let me keep going then. Okay. So that's what 100. With 25, it's really the same idea. Basically, what's happening is tax again is part, whole is the entire purchase. So really what we have then is over here, we have tax equals the percent, which is in decimal form, meaning it's divided by 100, or move to the space, or move to the left 2 spaces, same thing, times the purchase. But again, we're looking for the tax. That's why I'm doing this. So in this case of 25, we have 12.1 over 100 times 25, which is this. So that's all. I mean, here, of course, I rounded because, you know, we're looking at a purchase. So we have cents. Okay. I hope that makes sense. I mean, if you had is over of, am I recording? Yeah, okay. So I didn't know if I was recording or not. You could have is over of, I guess, if you want, and then they're asking what is 12.1% of a purchase of $25. So you could think of it that way also. I don't know if that helps but I hope it does. All right, anyway, so that's good. All right, so that's what we have. That's one example. So let's do another one. So here we have some poll. I just made this up that somehow 35% of all the people in a town said that they're going to vote for someone named John Doe. Again, I made this up, you know, it's hypothetical. So in part A, I'm saying, well, let's assume there's 1,100 people in the town. How many people are going to vote for John Doe? So here, what we're saying is part of the town's people, part of the town, excuse me, is going to vote for John Doe. What part? 35%. So we want to know what part is because we have whole, right? Whole is the entire town.